Okay, this is this last section of Chapter 2, which is Section 2.5, and it's going to be dealing with prime factorization and LCM. And prime factorization, if you've seen the factor trees, that's what we're going to be doing, the factor trees. And LCM is a shorthand way to write least common multiple, and we just did multiples in the last section. Okay, so we want to take a number and I'm going to start easy. Let's say 28. And I want to find the prime factorization for 28, which means I want to break down the number 28 into all prime factors. So when I'm done, all that will be left will be all prime numbers. And I'm going to use what we call a factor tree to do this. And you might have done this before where you put the number, like I'm going to put the 28 on the top of the tree, and we branch out. And we want two numbers that when you multiply them together will get you to 28. Two factors, when they're multiplied, will get you to 28. Well, some people might say 2 times 14. Some people might say 4 to 7, 4 times 7. It doesn't matter. It's all going to work out in the end. We're all going to get the same prime factors for an answer at the end. I'm going to do 4 and 7. So we put those here and here. Okay? So let me rewrite this. 28. I'm going to put 4 and 7. So again, you could put 2 times 14 if you wanted to do that. I'm going to do 4 times 7. Now we look at the branches. We've got a 4, we've got a 7. Are either of those prime? Is 4 prime or is 7 prime? Well, I'm going to say 4 is composite because 1 times 4 and 2 times 2 is 4, so that's more than 2 factors. 7, we talked about 7. 7 was a prime. So you're going to circle your prime numbers, and the tree's going to stop there. And the tree stops right there. Okay. But 4, I can branch off because 4 is not prime. It can be broken down some more. So give me two numbers, And we cannot use 1. I know we've used 1 for our factors, but we can't use 1 on the tree. So what are the only 2 numbers that when you multiply them get you to 4? 2 times 2. So again, we put the 2 factors, they're each of the branches, is 2 prime. Yes, because 2 times 1 is 2, that's all that works for 2. Okay, I can't branch off anymore, the tree stops. So these are all, we take all the numbers that are in the circles, and that's my final answer. So we say the prime factorization is 2 times 2 times 7. Or if you want to shorthand it, you could say 2 squared, and this is my answer. Two times 7, or like I said, shorthand, 2 squared times 7. And to check, if you multiply these numbers out, you get back to 28, you're right. So 2 times 2 is 4, times 7 is 28. We got back to 28, so we're good. And these are all prime numbers, 2, 2, and 7. Not bad. Let's go a little bit harder. We're going to find the prime factorization for 72. And if you have another way in the book, they show you a method called the ladder method. If you would prefer that, you can use that instead. I like the factor tree. I'm going to keep using the tree. But if anyone wants me to go over how to do the ladder, I can surely do that. So I'm going to do the factor tree, which means I'm going to put the 72 at the top of the tree, and I'm going to branch out. There's a lot of factors of 72, so any 2 factors, you can use any 2 factors of 72, just you can't use 1. Can't use the number 1. Let's see, we could use 2 times 36, 12 times 6, I'm sure 4 goes in, I know 5 doesn't. What comes to mind for me right away is 9 times 8. So I am going to use 9 and 8. And I'm going to put them on the bottom of my branches. Okay, remember we want to circle the prime numbers. Okay, is 8 or 9 or both prime? Is 9 a prime number or is 8 a prime number? I don't think either of them are prime. I think both 9 and 8 have more than 2 factors. So we're not going to circle in red because neither 8 nor 9 is prime. So we're going to branch off both of these. And I need two factors or two numbers that when you multiply them together will get me to 9. And remember, I can't use the number 1. So I can't use 1 times 9. What else? What are the only other two numbers that when you multiply them together give you 9? 3 times 3. So I'm going to put those on the end of my branches. Are those prime? Is 3 a prime number? Yes. So we're going to circle both of these. They're both prime because 3 times 1, or 3 and 1, are there only two factors. Nothing else goes into 3. So the tree stops there. What about 8? We cannot use again 1 times 8. What are two other numbers that when you multiply them get you to 8? Well, the only other two I can think of are 4 and 2. Okay. Is 4 prime or is 2 prime? I know 2 is prime. I'm going to circle 2. So that branch stops there. What about the 4 though? Is 4 prime? 4 is not prime because I can break 4 down to 2 times 2. 4 is a composite because it has factors of 1, 4, 2, and 2. Or 1, 2, and 4. And I know 2 is prime. Okay, the tree stopped. All I have are red circles. So I'm going to write these out. So I've got 2 times 2 times 2 times 3 times 3. I've got 3 2's and 2 3's. We don't have to write it that way. We have another way to write that would be 2 to the 3rd power. And I know I have 2 3's. So I can say times 3 to the 2nd power. And we can do a check. If we get back to 72, we know we're good. So let's multiply. I'm going to take my first answer and multiply it out. Well, 2 times 2 is 4. 4 times 2 is 8. And I'm running out of room. So 8 times 3 is 24. So it does get me back, let me bring that up a bit, to 72. So that's how you do the factor trees. And like I said, if you want to learn how to do the ladder, or if that's how you learned it with the ladder, do the ladder. Do whatever comfortable for you. Okay, those are my 2 examples. Last thing I want to do is least common multiple. That's the last part of chapter 2, and that's LCM. Okay, so they're going to give us two numbers, and they're going to say find the LCM. It's easier to write LCM instead of least common multiple. Now, this is how I do it. I list them out. You could also do a factor tree. So if you don't like this method, let me know and I can show you how to do this using a factor tree. So LCM for 4 and 3. We're going to take 4 and 3, and we're going to write out the multiples of 4, the multiples of 3, and the first place they have a common number, or the first place where they match up, that is the LCM. So do we remember multiples? Remember, we take, since we're working with 4, we take 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. Just take it out a little bit, maybe out to 5, and then stop and see if you're going to get a match. If not, we can always keep going. So remember, that's 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. I'm just going to stop there. Okay, for 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. Okay, I got a match. Easy. So 12, we say, is the LCM for 4 and 3. Easy? Or we can just list them out like that. Okay, I'm going to do one more, and that's it. So I'm going to want to write out my multiples for 12 and my multiples for 16, and I want to see where they match up. So this might be, you might want to use your calculator on this one, your TI-30. So 12 times, starting with the 12 times 1 is 12. And if you want to punch it in your calculator, 12 times 2 is 24. 12 times 3 is 36. 12 times 4, I'm just punching in 12 times 4. And 12 times 5, just punching in 12 times 5. I'm going to stop there. Okay, let's go to the 16 and write out all the multiples of 16. 16 times 2 is 32. 16 times 3 is 48. So I have a match. So 48 is the LCM. That's the answer. So try the homework on the prime factorizations using the factor trees and try to find the LCM for two numbers. And let me know if you have any questions, because I can always do more examples. So that's the end of Chapter 2.